Okay, we're almost done with the graphs. We're on number 21, which is our first log graph. And what I like to do with log graphs, I think it makes it a lot easier, is to put it actually in exponential form in order to graph it. Before we do that, however, let's look at log form and let's identify our parameters so that we kind of know what to expect. We would get a log base b of x minus h plus k. Remember, with a log graph, because this is the inverse of the exponential, our asymptote is going to be related to the h value. Okay, so x equals h will give us our asymptote. Okay, and our asymptote, remember, will be vertical opposed to the horizontal asymptote of the exponential function. All right, so let's look at the parameters. Our a value here is 3, which is going to represent a vertical stretch as always. Let's see, our base or our b value is equal to 5. Our h is 0. And k, notice, is also 0. This one is the one that will give us our asymptote, so we're going to have x equals 0 as our asymptote. You can put that in right away. It is a vertical asymptote on the y-axis. X equals 0. All right, now we're going to need some data values. Now where it comes in handy is to turn this into an exponential function because it's so much easier to plug in values in an exponential function. So in order to do this, I'm going to move this equation over here a bit and work with it. Okay, what we need to do first is get the log by itself. So we first have to divide both sides by 3. And we get y over 3 equals log base 5 of x. Now we can just rewrite into exponential form. So start with the base, 5, to the exponent, y over 3 equals x. Now this is the function that I'm going to work with to get values to graph. Notice that this function, we're going to use input values for y and then get the x values out. Okay? Now remember how we said we like to work with exponents in the range of -2, -1, 0, 1, and 2. In this case, that means that we're going to have y values. Let's just try -3, 0, and 3. We'll see if we need additional values after that. But actually, our base of 5 is so big that they won't be helpful. -3 in for y gives us an exponent of -1. 5 to the -1 is 1/5. Plug in 0 for y, you have an exponent of 0. Anything to the 0 power is 1, so 5 to the 0 is 1. Plug in 3 for y, you get an exponent of 1. 5 to the first is equal to 5. Okay, now let's go take those values and let's go graph them on our graph. Remember, we have to start with x first in order to graph. At 1/5 on the x-axis, we are at -3. 1/5, we're at -3. At 1, we're at 0. And at 5, we are at 3. Just with those 3 values, we've got a very clear idea of what our graph looks like. That is our log function. Notice the vertical asymptote at x equals 0. Let's talk about domain and range here. Our domain is from the asymptote all the way to the right. So we have starting at 0 all the way to infinity. Our range, would be all the way down to all the way up, so negative infinity to positive infinity. Okay, and then again remember our asymptote at x equals 0.